The show opened this morning, and our startup show now we have 272 companies. It's a leading startup show in Asia. We working together with our business leaders and our joint organizer, TCA. We invite companies from all over the world, especially to this show, which is on the way of transforming from reproducing to building global technology. So I don't want to wait too long for our keynote speakers to tell us, to share their insight with us. Thank you again for you joining us, and thank you for coming here to share with us your expertise and insight. Thank you again. Thank you.
我们是不是请秘书长先留在台上？我们接下来要进行合影留念。我们接下来要欢迎的是我们今天下午我们远从国而来的几位贵宾跟讲者，跟我们一起上台留念。We would now like to invite this afternoon's keynote speakers to please go on stage for group photo shooting. Ladies and gentlemen, please help me welcome Rene Haas, President of Intellectual Property Group ARM. Fan Ming Lu, Corporate Executive Vice President of Hong Hai Technology Group, Chairman of Asia Pacific Telecom Group. We'd also like to welcome Andy Rhodes, Global Vice President of IoT Solutions Group Dell. 我们在场所有贵宾，是不是能够借用您的双手，为我们今天下午的重量级的贵宾，来掌声来感谢他们今天下午热情的与会。So gentlemen, would you please put your thumbs up? Please put your right thumbs up for the photographers to take a few more photos. Thank you for joining us today, and that's it for the photo shooting. 我们再次的感谢台上的贵宾今天热情的与会。我们请所有的贵宾先行回座。Dear guests of honor and speakers, please return to your seat. And now is the moment that we've all been waiting for, the keynote session on future technology trends. There will be 5 keynote speakers this afternoon, as Walter had already mentioned during his keynote remarks. They represent ARM, Hong Hai Technology Group, Qualcomm Technologies, Intel, and Dell. And the very first speaker in the afternoon will be Rene Haas. He is the president of ARM's Intellectual Property Group, IPG, and he's also a member of the ARM Executive Committee. Mr. Haas took over management IPG this year and is responsible for all IPG activities, including product development, engineering, sales, marketing, and commercial operations. So without further ado, ladies and gentlemen, please help me welcome Mr. Rene Haas.
你好. Good afternoon. I know one of the themes of this year's Computex is about artificial intelligence and the ability to predict the kind of things that you don't know that you might need. And as I was getting ready this morning, I noticed I had left most of my ties back in San Francisco, so this was the only one I could actually find in the suitcase. And I think it actually turns out that there must be some AI, because I didn't realize that the color actually matches the stage, which I'm not sure how many ties in the world actually do that. So with that, thank you very much for giving us the opportunity to spend a few minutes with you today. As mentioned, I'm with ARM. We are the world's leading provider of intellectual property. And I'd like to talk to you a little bit about some of the things that we see going on in the future. And when I arrived here in Taipei for this visit, I kind of thought back a little bit, and I think this is probably the 10th year that I've been at Computex. I think I came first in 2007. And I remember landing in 2007 with my BlackBerry smartphone and just thinking, this was the cutting edge of technology in terms of being able to access emails abroad. remembering the days when the devices were never connected and you were traveling internationally and you didn't have phone service or you got faxes underneath your door. The world has changed an amazing amount. Looking forward, just in terms of the amount of devices that we have today that are connected, I mean, all of us obviously are connected in many ways with multiple devices. We carry them every day. And this trend is only going to continue to explode. When you look forward in terms of what the predictions are going forward into 2035, over 270 billion connected devices. And then when you think about the fact that the planet in 2035 is probably going to have about 10 billion people, that's a stunning amount of connected devices. And with those amount of connected devices is an amazing amount of possibilities. And we're obviously seeing that today. And some of the devices that are ubiquitous in terms of artificial intelligence or home devices or things for fitness have brought out trends that didn't exist years ago. I mean, for example, a Fitbit that counts your steps. Who knew that 10,000 steps was actually a goal? That was a number that one tried to achieve, and actually turns out it's probably about the right number, because I know when I do 10,000 steps in a day, I sort of feel it. But that's just the very beginning of what could be done with these type of devices. Today, these are essentially static devices, either devices that take information, they give information back to you in a personal way, but they're not really connected to a greater network, they're not really connected to a broader set of health areas or things that might actually help you going forward. So, these devices that, again, that if we look at as being really game changers, there's just a lot more that's going to be happening in this space. One of the areas clearly that's going to be a huge amount of growth, though, is in the area of robotics. I think many of you may recognize this device. ARM was purchased by SoftBank last year, and this is Pepper, who is the SoftBank mascot/robot. I first actually ran into Pepper in a SoftBank mobile shop in Tokyo. These little robots actually come up to you. They have a little tablet in the front. You can actually sign in. You can take your cue in terms of where you're going to be in line to kind of get your service. And right now, I think SoftBank's got several thousand of these devices, not only installed in their shops, but also with partners abroad. But again, this is a very, very early stage type of development. When you think about the type of potential that could exist with robots in the area of healthcare, things like the Da Vinci project here in Taiwan, other areas in terms of personal assistance, this is an area where there is huge, huge potential for growth. When you think about adding things like empathy and feelings and emotions that have to go into what goes inside a robot, there's just a gigantic amount of potential in terms of what can be done there. And this is, again, just scratching the surface. Going forward, when we think about robots and we think about this field of robotics, not only is there a tremendous amount of potential in terms of what can be done from the marketplace, but it is a place where our company works a lot with several partners in this area. ARM develops a lot of leading technology around processors, around GPUs, around vision processors, and in each one of these areas, whether it's either in the mechanical movements or in the positioning or anything relative to how the device needs to operate, this is a critical area where the functionality is very, very important. Inside one of these devices, you can imagine there are hundreds of processors. These processors all have to work with each other. They have to work inside a unison. Security, huge concern. Safety, huge concern. A lot of the elements that kind of go into it really, really pervade in terms of what the next generation of technology could provide. And I think one of the key areas, again, around this is that the AI component to this is really just starting. These devices are very, very early stage in terms of how they operate, how they learn, how they take information and process it to get better the next time, not unlike a human brain. But this is where things are going. And as we started to think about this whole broad area of artificial intelligence and what its impact might be to the market and how people viewed about it, one of the things that our team did was we commissioned a study around AI. And again, broad term, right? I mean, artificial intelligence means a lot of things to a lot of people. but it was really sort of in the area of how are people sort of thinking about this globally, because the impacts that it can have upon the global society in terms of health, in terms of safety, in terms of social infrastructure are very, very significant. And you can see by the numbers, the markets are starting to get ready. And I was really struck again when I thought about coming to the show. I remember there were a number of years around these technology shows where people were saying, gosh, there really isn't anything new to be invented. Sort of reached good enough in terms of where we are with technology and how many more tablets can we build, or how many smartphones can sort of look the same. And I think when we think about artificial intelligence and its impact to the market, we are in really an unknown time for us in terms of potential for disruption. It's an extremely exciting time. And you can see the way the market is sort of thinking about it. The world is starting to get ready. We went through sort of the same analysis here in APAC. We asked the same questions of folks here inside Taiwan. And it was interesting when we sort of extended this to other areas inside APAC. There were similar themes, but a little bit different. People thinking about things like companionship and how things can impact their lives. A lot of studies that we did with folks that went through in Japan that looked at how these robots or how these artificial intelligence devices can actually be better in terms of assisted living, what that looks like, etc. So the market is definitely ready. And I think for all of us in the technology field, it represents an amazing opportunity for us in terms of the next wave of innovation. At ARM, we've been doing a lot of work in this area. Specifically, when you think about implementing artificial intelligence and complex algorithms at the client level or at the chip level or even at the micro level, there's a lot of things that need to take place in terms of maximizing performance and maximizing the capability of the machine. We introduced a technology called Dynamic. In fact, we did it about a month ago. We talked about it yesterday at one of our product launches. It's really about the idea of adding more and more capability to SoCs, adding instructions for artificial intelligence, adding ways that processors can work together. Many of the SoCs that are inside these robots have 2 processors, 4 processors, 8 processors. There are CPUs, there are GPUs, there are vision processors. There's all kinds of different processing elements that are going on. These client devices are going to be increasingly more complex. They're going to be increasingly pushing the areas of heterogeneous computing, i.e. more processors on a chip. And even though there's been a lot of talk about Moore's Law and where Moore's Law is going, things are dead, I think everything going on relative to all of these processors inside a single SoC is a gigantic opportunity. And for us, we've invested very heavily in this area, and we think it's extremely important going forward in terms of what the opportunity space looks like. And that really leads itself to fundamentally what the world looks like in terms of AI and in these chips and in the cloud and in the client. And one of the trends that we see kind of going forward is that AI is not just about a chip, AI is not just about a client device, AI is not just about a network device. It's really a continuum of devices across a broad ecosystem requiring many, many partners to work together. One of the things that we're most proud of at ARM is how we work with a broad set of ecosystem partners, people who are in the software space, people who are in the hardware space, people who are on the client side. And going forward, if we kind of think about where the world is sort of going, in the early days, a lot of these devices operated rather independently. But as the trend sort of moves forward, there is going to need to be very, very significant system-level implications. This is, again, uncharted water for the industry relative to working together, developing standards, developing ecosystems around each one of these nodes. Each one of these areas will be a high level of complexity. Each one of these areas will require a high degree of security. And also, each one of these areas are going to require an unprecedented level of partnership between companies to work together to make it happen. One of the beliefs that we have in terms of the needs of the end market in terms of artificial intelligence is what we call AI at the edge. If you think about everything that goes on with cloud computing today and everything that essentially happens on your client device, and then you have to pop a few nodes to the cloud to make a decision and then pop a few nodes back. That works okay for certain levels of applications, But as the data bandwidth continues to grow and grow and grow, and every time that people look at the statistics, it's essentially an insatiable demand for data. The latency of the networks is not going to be able to keep up with the complexity of the data. And more importantly, security of the information is going to need to be protected across the way. So we believe that not only is the AI trend going to be very significant in the cloud as it is today, and all of the things going on with hyperscale computing and things of that nature, we also believe that at the client device, it's going to be very, very important to have the AI type of capabilities. And this means security, this means ability to address latency, and also, frankly, low power, which is extremely important because in client devices that have limited battery life or may have batteries that are never replaced, and then you think about AI learning, light switches that learn, thermostats that learn, fans that learn, devices that are today simply electric devices with no type of capability. Imagine going forward, these devices will have the ability to self-teach based upon patterns, self-teach based upon what's going on. I'm sure many of you have sat at traffic lights, at maybe 5 a.m. in the morning, and you're waiting and it's red, and everything coming through is green, yet there's no cars. That's really a simple example of something that needs to improve to be a learning-based system that can not only learn based upon the time of day, but is doing real-time analysis in terms of traffic flow and things of that nature. Those are just small examples of things that are going to get pushed to the edge. They're going to happen really all over the place. Training is going to get to be a very, very important component. Devices that can learn, devices that can identify what needs to get done, and essentially be able to have that type of processing be done in a very quick way. That's going to drive demand for processing at the edge. That's going to drive demand for security. That's going to be a very significant opportunity for everyone in this room in terms of growth, and it's an extremely exciting area. Now, there's a huge amount of momentum going on with artificial intelligence in all these spaces that we talked about. I talked a little bit about robotics. I talked a little bit about surveillance in terms of security and cameras. The home is actually an area that we are seeing exploding growth, and I'm sure everyone who has devices in their home can personally relate to this. It's a space today that where we work with our partners in multiple areas. So some of the products that we build, again, whether it's the CPUs or the GPUs or the vision processors, are enabled in all types of devices in the home. Again, whether it's areas in terms of control, areas in terms of interfaces, areas in terms of what the remote controls can do. But again, this is just really scratching the surface. These are smart devices in that they are smart in what they do today, but the devices don't learn, right? The devices don't understand patterns. The devices don't understand what trends look like. And the processing capability in these devices will only grow. Today, it's a very, very significant space where we have a lot of engagements with our partners, but going forward, these processors in the home are just going to continue to grow and grow. One of the areas that we're most excited about, though, is computer vision. We invested at ARM about a year ago and brought some technology into the company around computer vision, and we look at computer vision in terms of processing as yet another processing application. So again, you have central CPUs that do a lot of control, you have graphics processors that do all of the imaging and the rendering, but a computer vision processor that can actually capture the images and make intelligent decisions on what those images are and what they do is going to be a very, very powerful area that we feel. So we've made some investments in this area. We're working very closely with some end partners. And you can start to imagine just what some of the applications might be. Again, there are security cameras located all over the world, located in all kinds of areas, whether it's in airports, whether it's in buildings, whether it's in traffic areas. But the level of intelligence in these cameras today is actually quite limited. The images are captured, 99% of the data roughly, and that's a rough estimate, that isn't used, isn't analyzed. It just kind of goes to the wayside. And that's simply because the volume of information that is captured is just too large to be able to do any type of real-time analytics on it. If you have a vision processor and you have learning at the node, you can start to not only capture images, but you can start to take images at certain times of the day based upon people that you know or things that you know that should be there, that should not be there, etc., and can do a lot of real-time learning. And this is just an area where, again, having local capability, doing local type of processing, doing local type of security, doing local type of encryption is going to be very important. Security is going to be very, very critical in these areas. You have a tremendous amount of data at the source, these images, these visions that are brought in. You don't want them compromised, you don't want them hacked, you don't want them to go from the source to the network to the cloud and back and be interrupted. So having intelligence at that client device that's doing the type of security work to keep it safe is going to be very, very important. So again, we believe that computer vision is a huge, huge growth opportunity for our industry, and we think it's not only going to be in the area of just capturing images, but things around security and things around access. One of the other areas that we're hugely, hugely excited about, and you see a lot of it continuously being talked about, not only at this show, but many others, is the automotive area. Automotive for us is a giant computer network, the way we think about it at ARM. Whether you're thinking about IVI, or you're thinking about chassis, or you're thinking about the powertrain, or you're thinking about ADAS, or you're thinking about telematics, these are all complex computers that are doing very, very complex calculations, and largely in an independent way. So today, we looked at this is a hypothetical example of what we call the Cortex automobile. There are some cars out there today, some models that have over 100 processors inside them today. Most of them are ARM-based, I'm happy to say. But in those cars, the processing elements, again, largely do not work with each other. You may have something that was designed in a module that was for the drivetrain that doesn't exactly talk to the instrument panel in terms of the IVI, that doesn't necessarily talk to other pieces of the equipment. And that's largely because the automobile has continued to evolve relative to a set of modules that are designed separately, the timing of the products are developed separately, etc. That's all changing, and that's a giant opportunity for the entire electronics industry, which is why everyone is so excited about what's going on with automobiles. And that's not to mention everything that's going on with autonomous driving and everything that's involved there. We think, again, not unlike the security example, not unlike the home example, there's going to be a lot of intelligence that's going to take place in the cloud. There's also going to be a lot of processing that needs to take place inside the car. And it's going to need to take place inside the car locally, decisions made locally, decisions that can't go back and forth to a cloud-based device to make a decision on where to go. And that's both a function of latency, but also really a function of real-time safety. You don't want cars that can have to depend on other cars in terms of how they move back and forth. So the automobile industry is really at an inflection point. I think everyone here realizes that with everything that's going on. We think going forward, there's going to be an unprecedented amount of electronics content, semiconductor content, software content that's going to push the edge in terms of what gets done. One of the things that isn't always talked about, though, is power efficiency in a car. Now, a lot of folks will say, how can you possibly have a power issue in a car? You've got a large battery, you've got a large engine, you're generating a lot of power. This is a little component, how can you possibly worry about power? But actually, it's a pretty large issue for a number of reasons. First off, there are limited capacity to these batteries. Secondly, you are putting devices in some cases, whether it's inside and embedded in the mirror, whether it's a sensor in the back of the car, other areas that you actually want to minimize the amount of cabling, you want to minimize the localization of power that's going back and forth. In some cases, these devices might run on their own battery source. So efficiency is actually going to be very, very important going forward in autonomous driving. And again, people maybe have not always realized that the battery life of a car at some point will tend to begin to look like even your laptop battery in terms of you want to do everything you can to be as efficient as possible. And particularly when you think about trying to extend the ranges of the cars, trying to make sure that the minimum amount of work is being done by the electronic subsystem, you're going to want to be very, very intelligent about how the power is managed inside the car. So the automobile is going to represent a very significant opportunity in terms of power management. And in ARM, that's something that we spend a lot of time and energy on. It's a big focus for us in everything we do relative to technology. We think it's going to be critically important going forward. So now I've talked a little bit about some of these areas, and I just wanted from a high level give you the vision of what we think is important going forward. ARM technology, we like to say, is involved from sensors to servers. We're really across everywhere in the value chain. And that's largely because we do a lot of technology that is not only applicable for these markets, but we work with some of the greatest partners in the industry to make these markets happen. So we spend a lot of time and investment around the enterprise and server space, obviously mobile and consumer, where people associate ARM, but also automotive and robotics, as I talked about, and then embedded connectivity. The ARM business model is really about enabling partners to innovate around building products that are the right solution for the right application. So we work with thousands of folks, a lot of the partners who are here today, and a great degree of thanks to everyone there. And again, my thinking is that if we look kind of what is going forward, as I mentioned before, relative to the technology space, whether it's autonomous driving, whether it's AI, whether it's other areas, this is an unprecedented time for us in the industry, and I think we're all extremely lucky to be working in this industry at this time. For us, going forward, we also see an amazing amount of growth. If you look at ARM's history, we started in 1991, as you can see, and it took us about almost 20 plus years to ship 50 billion devices. And we're predicting that in the years 2013 to 2017, we will ship about 100 billion devices in addition. So we are now at about 100 billion chips total between our partners. And I think there is a statistic out there that says, I'm not sure what the source of it is, but when people look back at the amount of people who have lived on planet Earth, who are either dead or alive, that number is about 100 billion. So we have shipped a chip for just about everybody who is dead or alive on the planet. That's to date. But going forward, we think in the next near years, we will ship with our partners another 100 billion devices. And the growth that we're seeing is really a function of everything that I talked about relative to all of the processing that's taking place, whether it's in the cloud or in the client, et cetera, et cetera. Going forward, we think that number gets to a number that is around 1 trillion devices. Masayoshi Son, who's the founder of SoftBank, I think had mentioned once in a keynote speech about reaching 1 trillion devices. And when you think about 1 trillion devices on the planet and what that means in terms of connectivity and the networks and the security, it's just an amazing opportunity. And we think with that, ARM, but more importantly, ARM with its partners, the ecosystem, the key partners that we have in Taiwan, are really on the cusp of doing some amazing things together. And we like to think about it in terms of what can really be done and what can be architected and what is possible. So with that, I'm going to close here, and thank you very much for listening to my talk here at Computex, and a small video to close the session. Thank you.
We didn't ask why. We asked why not. We look, we seek, we find, we uncover. We are the optimistic architects of tomorrow. At ARM, our partners have come to trust us, to craft everything from the core of what drives it to something that makes lives simply better, simply smarter. Smarter homes, smarter phones, smarter cars, smarter communities, smarter cities, smarter world. The billions of things connecting us, bringing us closer together, making us healthier, making us happier. And this is only the beginning. What comes next, and next, and next, is ours to blueprint. Success is measured through our partners' freedom to dream, to build and to create the seemingly impossible, making the ordinary incredible, thanks to what is at its very essence. The possibilities are limitless. The outcomes are endless. At ARM, we can go anywhere our intellect and our imagination take us, because anything, everything, and all things are possible.
for joining us this afternoon. And ladies and gentlemen, today's second keynote speaker will be Fengmin Liu. He is Corporate Executive Vice President of Hong Hai Technology Group, as well as Chairman of Asia Pacific Telecom Group. Mr. Liu leads Hong Hai's Cloud and Network subgroup and plays a crucial role in extending the group's entry into the telecom broadband service, as well as digital convergence market. And before his presentation begins, I would like to remind you that any sharing, distribution, dissemination, online or in the physical manner of any of the presentations and their contents today are prohibited without obtaining prior approval from the original authors. 在今天接下来的这场演讲开始之前，我们要再次的提醒在场的所有的贵宾，今天所有的演讲的内容的上网分享、报道或者是转载，请您务必要取得原作者的同意。So without further ado, ladies and gentlemen, please help me welcome Fengmin Liu to the podium.
各位午安，端午节快乐。Good afternoon and happy Dragon Ball Festival. Before I was instructed to come this keynote, I prepared by Mandarin, by Chinese. I didn't know that today I need to use English to make the presentation. So I hope that my English presentation can present my quality of the Mandarin. So, thank you. Great to have this opportunity in Computex today to share with you about the Foxconn, the smart factory, the IoT implementations. So before my implementation, today actually I tried to split into two sections. The first section, try to share with you about the macro view. As a corporate, when we talking about the development strategy, definitely we need to thinking about the overall, what's the world is going to be, what's the industry is going to be. Then definitely we need to thinking about what's cooperation can be rapidly to address the change. So that's mean what's our strategy. So the first section will share with you what's our study and also our implementation of the industrial internet, the smart factories approach. So that's the first section. And the second section, I will borrow 2 slides and 3 videos from last week. Our chairman and CEO, the Terry Guo, he made the keynote in Guiyang, the Big Data Expo. So we'll pretty much, I think, borrow his 2 slides to share with you about how Foxconn to implement the smart factory. Okay, so let's start it for today's speech. Looking into this 2020, or even further about 2025. Okay, so the world is changing very, very drastically. Okay, nobody will talk about how many population will be connected, how many devices will be connected, even the created, the content, the data going to be. So the slide actually is telling us more and more people connected. There's going to be 7 billion people are connected. And also, not just only people, also the devices. The estimation will be about 30 billion devices going to be connected. Okay, that's we mentioned about the IoT. Okay, then more and more data will be generated. It's not just only professional data, also user-generated data. Okay, so you see, 70% using smartphone for the people's connection. Then 46%, that will be machine-to-machine connection. So when we're looking forward about the 2020, even looking forward about the 2025. So what this slide means and present the information to us, the big data behind. Okay, so that's the first. We need to not just only, I think, focus on our work today, but also forward-looking. Talking about the overall connected device, then next will be the era of the IoT. Everybody's talking about the IoT. Okay? Then what's the IoT going to be impact to our overall economic value? So refer to our study, okay, coming from McKinsey. The impact will be 11 trillion US dollars economic value. Within these segments, the manufacturing actually contribute the most, 3.7 billion US dollars contribution. Definitely, it's not just only manufacturing. If you're talking about infrastructure, Medicare, retail, even logistics, again, it's very huge. 1 trillion US dollars economic value is huge. So many of the segment, but top of the segment is manufacturing. Don't forget, in the past years, majority of our focus, including media's reporting, including talents graduate from the school, try to search for their new career, their job, even the investors, to make an investment, always be emphasized on internet, always emphasized on the virtual economy. It's not emphasized on the physical, the real economy. And manufacturing actually is representing the real economy. It's not just talking about that more efficiency, even push for the sales growth. That actually, this is the numbers we need to address. Economic value of the IoT era. So everybody talking about IoT. So this is the impact to our environment. Okay? Talking about everybody make an investment into the virtual economy. Okay? But cannot be ignored. The manufacturing industry. 2016, Department of Commerce, USA, they make the analysis. Every individual dollars spending in the manufacturing can create another 1.8 US dollars a day from the other associate service. Then $1 spending, one headcount create in industry can create another 4 headcount in the surround economy. So that's how important. So manufacturing, significant impact to the GDP. China, Taiwan, pretty much, I think, still has 30% that's counting on the manufacturing. USA, since 70s, is coming down to 12%. But now, Mr. Trump is declared made in USA. Try to pull all the manufacturing back to USA. It's just only USA? No. Modi, the Indian, try to make in India. So that's the scenario, right? Germany still at 22%. So how important for the real physical, the economic will be impacted by the IoT and also that contribute to the nation's GDP. So since 2011, America announced AMP. Then 2012, Germany announced the Industrial 4.0. All the way down, everybody re-emphasized the physical economy. Doesn't mean the manufacturing. Okay? So since many of the audience is coming from Taiwan. So Taiwan also 2015 announced the productivity 4.0. But compared with other nations, like Germany, like America, they already announced the detailed implementation plan, not just only the strategy, also the implementation plan. Okay? So for us, I think this is very critical. So G7, you can see, is in here, including China, the China 2025. Okay? So again, emphasize how important, how critical for a nation to emphasize, focus on the physical economy. Then another angle to see what's mean advanced manufacturing. So the study actually is mentioned about, okay, all the global CEO, the survey come up, emphasize on advanced manufacturing, that including how to use the big data that generated from the manufacturing, that can predict anything, even the smart connected device for the IoT, advanced material, smart factories, also digitalized for simulation, for integration, and high performance computing. When we mention about IoT, when we mention about how many devices are connected, we need a superpower of the computing power to calculate. So we just see the AlphaGo, right? Win the chips, right? So again, definitely we need a high performance computing. Not just only that, advanced robot, that's 3D printing, even the all the connection. It's not just only emphasized on manufacturing alone. We need to thinking about from the consumer's perspective, coming back, what's the consumer's requirement? So leaning back to the manufacturing. So when talking about advanced manufacturing, it's not just only thinking about manufacturing alone. We need to thinking about overall from the consumers to the manufacturers. Okay? Then also including the AR. So that's the definition, the requirement for advanced manufacturing. So talking about this top, the predictive analysis, IoT, that including high HPC. So these segments are the items actually we are very focused. So later you will see what's our implementation to address this couple of the key requirements for the advanced manufacturing. Industrial 4.0, the structure is not just only physical manufacturing, also how to integrate both cyber and the physics. Cyber means all the information, internet, from the software, from the user interface, to the computing power, connected network, until all the equipment, all the manufacturing, the physical manufacturing. All this individual technology actually is quite mature today. Surround us, we know all this individual technology. But how to integrate all this technology, combine together to address for the next generation's requirement, to generate the platform, the ecosystem, to support. So the machine is not just only use the menu, the stack, the engineer to adjust, to configure. Can we let the machine become smart, become intelligent? So when the machine gathering all the information during the production, then can the machine be self-aligned, be self-configured to address, okay, how to assure from piece 1 to 1 million piece, even 10 million piece, can be consistent, the result. So all this cyber and physics, the technology can be integrated. So the application can be adopted into the smart factory. Okay? That many of these solutions can be addressed, including that modular production, even a smart product, predictive maintenance, the smart environment, even collaborating the robot. All these kind of applications can be adapted into advanced manufacturing. Okay? So Foxconn's approach based on all this technology. So Foxconn, actually, we are a mechanical-based electronic company. We start from the component company. So we have the great tooling, machinery technology. Then we are pretty much migrate from the component company, become a high-tech company. So that step into, we call it ODM, even the high-end manufacturers. So as a manufacturers, definitely we do have huge of foundations, technology foundations to support our competition, to support our growth. And beyond our original core technologies and our foundations, and we are implementing in our production floor the sensors. Even we are building up the cloud and network infrastructures. Then beyond that, also we are developing the platform. Some of the platform we can collect all the production informations. Okay? Then we are pretty much putting on some of the applications I just mentioned in the previous slide. That's we call the service as a software as a service, application as a service. Okay? So this pretty much Foxconn's approach to address, to implement. That's what we call the industrial internet. Foxconn's smart factory approach. So from this slide, actually, the next cartoon I try to share with you. The most important, again, yes, we mentioned about we can implement all the sensors in the production floor. We can have all the computer, the data center, the network device, the equipment can be smart. But the most important still, every individual company's foundation. For example, TSMC, the foundation for TSMC still competition for the 10 nanometer down to 7 nanometer, even down to 5 nanometer. That's the foundation of technology. Even the previous presentation about ARM, they still need to emphasize on their core technology, the low power, high performance CPU. Similar for Foxconn, we must build our foundation. Okay, so all the implementation above the core technology, actually we treat it as a wing. Okay, so the cartoon like this. If you are in the industry, you are tiger, then all these sensors, all this platform, all this application will help you like a flying tiger. But if you are mice, then you only become a bat. Okay, don't forget, everybody talking about the smart factory, talking about the intelligent advanced manufacturing, right? But the most critical will be your core technology. You must have your own core technology. Then you can have the futures, right? When you add the internet, when you add the IoT, then that can help your company become flying tiger. Okay? Then next, the emphasis is not just only manufacturers alone. Need to thinking about the supplier partner. Need to thinking about the overall, the industrial value chain up to the consumers. So that's why our strategy pretty much is component to consumer. That's the overall ecosystem. The implementation need to be addressed, not just only the manufacturers alone. We need to think about whole the industry, whole value propositions. Okay? So before this slide, pretty much just offer you a background. The overall was changing. What's the next trend? Then what we analyze ourselves, then put it on the implementation strategy, development strategy. Okay? So next, try to share with you about Foxconn's value proposition. So this is a realization of our industrial internet. We define ourselves, our smart factory, our artificial, intelligent factory. So this is based on the previous slide. So we are implementing all these sensors level infrastructure, and also the platform, and also the applications to support. So up to today, actually we have the 5 smart factory in place. That's a smart factory. Actually, we turn off the light, no light in the factory. Okay. So, and also we are developing that Industrial 4.0 demo site. Again, we are pretty much, I think, coordinated to develop, we call the smart campus, smart factory type. It's not just only production floor. Okay. So, in general, talking about Foxconn's implementation, we are pretty much, I think, starting from the first one, automation. So up to today, we have about 60,000 robots are in place in our production floor. Second, connected. We pretty much implementing the network to connect all the, not just only device, not just only material, also including the people working in the production floor. And digitalization, definitely. We need to have a base. When talking about the big data and analytics, even how to use the artificial intelligence approach, we need to have a digitalized background, the foundation. Okay? So that's our implementation. So today we have amended, we are pretty much informatization and also fully document for our production floor by video image. So that's the today's result up to today. Okay? Then when we mention about the smart factory in Foxconn, we pretty much, I think, measure 6 categories. Okay? The number 1, we emphasize on industrial big data. Number 2 is a smart factory. Number 3, looking forward. Actually, today I understand all the video image still 4K. I think majority of our household still 2K today. 4K pretty much just started, right? If we go to the electronic shop today, pretty much you can easily to buy the TV. But looking forward, if we try to have the smart factory, if we try to have the real advanced factory, we need to have a even ultra high definition of the image in place in our production floor. When we're talking about all connected, again, today's 4G, even today's Wi-Fi, all these machine-to-machine connection protocol, actually is not enough. So we are pretty much also emphasize on next generation of the R&D for the 8K and 5G. When we're talking about the smart factory, that's turn off the light and no people over there. How scary, right? Because if we got an attack, that will be very dangerous. So that's very, very critical. We need to implement the data security to assure, be sealed, be protected. Okay? And overall, it is not just only individual applications. It must be integrated the ecosystem, the platform. Okay? Then again, when we're talking about a smart factory, definitely we need to have a high performance computing together with high volume data storage. That's the 6 category key items that we are emphasizing. Okay, so next, share with you about our practice. Have 3 videos. That's real life applications in our production flow. Okay, so let's show the first industrial big data. So this is a panel shop, and we are pretty much adding all robotic, also connected. All the measure is through automatic measure. Then even for the glass, the coating, the thickness, we are all measured by automatic. And also not just only provide automation inside the production floor, also we offer the remote, the controlling. So engineer can be remote to access all the information, the data. So even during the production, we can gather, that's mean data acquisition, to gathering all this glass thickness, right? So we can use all this data and predict the yield rate and quality output for the coming batch. It's not only today's batch, it's a forward-looking, and adjust our equipment. So that's pretty much, I think, the one, how our factory use the data acquisition, then become the intelligent analytic to do some projection and prediction for the next operations. Okay, so that's the one. Actually, we are pretty much, I think, putting a lot of effort on this one. The next will be the smart factory. Okay, please show the next video. So all the machine is connected. The robot is not just only machine to machine, also things with things, machine with people. Even we have the AGV to transmit all these toolings. All these robot, actually, you see, we are heavy users for the all #1 tier 1 robot companies, but also we have in-house robot development. And again, this is the platform for the data collection and analysis, become a data bank. So that's our turn of the light factory. Okay. Then next, why we try to continue to invent, to spend the dollars for the R&D, for the AK and 5G. Okay, the reason because looking forward, we are pretty much, I think, use the security as an example. But looking forward about the automatic optical inspection, that we need to have a very, very high definition of the video image to help all the production flow. Okay, so next, please take a look about the AK and 5G projection. So AK and 5G, our definition, it will be the smart factory's foundation. All the ultra high definition going to be smart factory's foundation. So this is our optical inspection. For all the scratch, you can use all the automation to check. Okay, when you see one of the video image mentioned about the HD, 4K, and 8K, right? And some of the HD is still fuzzy, right? But I think everybody will be questioning, how come I see the HD is so clear, right? But when we're talking about this, is when you have the image, for example, when I take a Photoshop here, okay, to capture here, all the Photoshop, then because the distance is easy, that's only for 2K HD, good enough. But when you see the tablet or even the smartphone, when you zoom in, if you use the HD, when you zoom in, it can be fuzzy, right? So similar, actually, I think a Super Bowl just demonstrates about how powerful of the 8K. They are using the 8K camera, just have the big pictures capture. That's pretty much like 100 meters or 200 meters. They catch the overall, that's a Super Bowl, that after the Super Bowl the ending, that the jersey got steal, right? So they use the 8K to zoom in, so clear, they can catch the person. That's a couple hundreds people, 100 meters away, right? But use the 8K, easy to zoom in and catch that so high definition, the clear image. Okay, so similar, during the production, when we mention about more and more precision, right? Today's technology for the glass, for the housing, is more precise. Even the technology inside the foundry is talking about 10 nanometer, 7 nanometer, right? So again, the ultra high definition 8K image, we feel that's going to be the trend. It's not just only used in the manufacturing, also can be in the precision surgery. That we already see the operation practice in Tokyo. Use the 8K that definitely, okay? So can be very precise to have the surgery. So a lot of the new application, security, manufacturing, all can be adopted, all this, okay? So that's the video share with you about the implementation today Foxconn doing, okay? So where are we? Foxconn is moving forward. That's the past. Before the 2010, that's Foxconn about 2.5. Okay? Even the assembly line, we already have many of the robot automations. But today, actually, we have the 3.5, including all the data, including all the, not just automation. We are pretty much using some of the AI technology and also predict and configure for our equipment. And definitely, we are just starting, okay? Overall, how many facilities around the world? We just only have 5 fully turn off the light factory. So still, just only about 10+%. We understand we need to continue to make the investment, okay? Then the futures, definitely, the component to consumer, that will be us try to implement. So Foxconn, as the largest electronic device manufacturers, and we do have huge of the database in-house. Again, we have a reach of talents, and definitely looking forward, just only the talents, we need to have more investment. So we committed to make more investment to build the R&D, and also we try to build the independent, the business group to emphasize on the industrial internet. And we hope we can become benchmark business group in the industrial internet industry. That's a new industry. So that means it's not just only the largest electronic device manufacturers, but also we can share our platform, we can share the data with our partners, with our customers, with consumers. Then we can provide the technology and also the platform to support the small, medium companies, our partners, even all the value proposition, the partners together. So that's our hope, our plan, our vision for the next. So we will continue to make investment, okay? So, look at here, pretty much the Foxconn, we emphasize on a couple of the categories. We're talking about the cloud investment, we're talking about the mobile, we're talking about IoT, talking about the big data, and also the artificial intelligence, network. Definitely, don't miss the robot. The robot will be our base. Okay, so in Chinese, I think we mentioned about 云移物大智网加机械人. So that's our pretty much the strategy for our industrial internet approach. Thank you very much.